In this video we are going to see what is p-value. So if it's the first time you are trying to understand this concept, it might be a little confusing for you as it was for me. So let's go step by step that how can we calculate p-value and how can we decide whether or not to reject a null hypothesis using the p-value obtained. So to calculate the p-value, first of all we have to assume that our null hypothesis is true. So we have to assume a distribution which our null hypothesis specifies. And let's say that now we observe a given observation x, and we have to decide that how likely is to observe this observation, given we have already assumed that the distribution is as specified by our null hypothesis. So what we do is that we find the probability of getting a value x or a value even worse than x, that is a value which is against the null hypothesis and in favor of our alternate hypothesis h1. So for example, let's say in this case, which is the case 1, let's say that our null hypothesis says that the distribution is a normally distributed distribution with mean mu naught, and let's say we observe the observation x. So we calculate the probability that the value is x or even worse than x and favors that the mean is not mu naught. So if the mean is not mu naught, then we can expect a value which are large values. If the distribution is a normal distribution with mu naught, and if the mean is higher, then on an average we will expect larger values from h1 distribution than h0 distribution. So to calculate the probability of getting value x or a value worse than x that is in favor of h1, we will find the probability of getting the value x or a value larger than x, which is this area. So we'll calculate the probability of getting a value within this region, given that we have already assumed that null hypothesis is true. So if the null hypothesis, let's say that this area comes out to be 0.05, so then we decide that should we reject the null hypothesis, or we can't reject the null hypothesis. We can't accept the null hypothesis based on p-values, but we can decide whether we can reject or not reject the null hypothesis. So now the third point comes. If the p-value is low, which means that it is unlikely to get a value x or higher, which means that if we assume null hypothesis is true, if we assume that mean is mu naught, but we calculate what's the value of getting the value in this region which is marked in green, and if this probability is low, then we can say perhaps x does not belong to the distribution as specified by null hypothesis, because x is so far away from the mean that this value is so low that we have to reject the null hypothesis. So this is the basic idea behind p-values. So for example, in this case too, let's say our null hypothesis again says that we have a normal distribution with mean mu naught, but our alternate hypothesis says that no, our mean is much less than mu naught. Then again we'll calculate the probability of getting the value x or a value which favors h1, that is a value lower than x. And if this value is low, then we can understand that the given observed value x is very far away from the mean mu naught, and perhaps we should reject the null hypothesis because we do not have sufficient evidence that the given observed value might belong to a normal distribution with mean mu naught. And in this case 3, let's say our null hypothesis is that we have a normal distribution with mean mu naught, but we get an alternate hypothesis that no, the mean is not mu naught, it's something else. So it's, in that case, let's say we observe any value x and we'll see the absolute value of x. So if mean is not mu naught, which means alternate hypothesis is saying that a value is much farther, either very higher than mu naught or very lower than mu naught. Then in that case we have to consider both of these areas. And if these areas are very low, then we can understand that perhaps the given value x is not from the distribution as specified by the null hypothesis, and perhaps we should reject the null hypothesis. So the general rule is this, that we obtain these probabilities which are known as p-values, which are the area of the shaded green region, and we decide a certain threshold. If a p-value is less than the threshold, then we reject null hypothesis. And if p-value is not less than the threshold, then we cannot reject the null hypothesis. Let's consider a small example where we have to test the null hypothesis that the height of 7th graders has not changed, and the alternate hypothesis that his average height of 7th graders increased since previous heights. So let's say that someone observed the height of 7th graders 5 years ago, and average height was 145 centimeter and standard deviation of their heights was 20 centimeter. Now some teacher samples 200 students from 7th grade at present and finds that their average height is 145 centimeter, and let's say we decide a significance level or a threshold to be 0.05. Then we say that we create our null hypothesis that the average height is 145 and it's not changed. So the distribution, we assume that the distribution of heights is still the same as it was 5 years ago, and we have to decide whether we can reject it or not. Alternate hypothesis that no, the average height is not 145 and it has increased since then. So the first step is to assume that null hypothesis is true. That is, we assume that the distribution was same as earlier with mean 145 and standard deviation 20. After that, since we have sampled 200 students and we have their means, which is the average, we have to find what would be the distribution if we sample 200 students, what would be the distribution of the mean. So let's say we have 200 samples, x1 to x200. Then by basic probability formulas, we can easily get that the distribution of the mean of 200 samples would be a normal distribution with mean 145 and a standard deviation of 20 divided by root 200, and we have to find how likely is 147 from this distribution. So if 147 is likely to be from this distribution, then the p-value will not be very small, but if it's not likely from this distribution, then p-value will be quite small. So to find that whether 147 belongs to this distribution is similar to finding that 147 minus 145 divided by 20 by root 200 belongs to normal distribution 0 1. So again, this is basic probability mathematics, and you can google it if you can't understand this step, or maybe I'll create another video sometime for that. So now we have to think that whether 1.414, how likely is it to be in to belong to a normal distributed random variable with mean 0 and standard deviation of 1. So let's see this figure. So the observed value here is 1.414, and the area in favor of alternate hypothesis is this, the green one, which is all the area greater than 1.414, and the threshold is 0.05. So usually people remember this value, that for a normal distribution, whenever the threshold is 0.05, whenever this area is 0.05 on the right hand side, the value corresponding to that is 1.64. And since our value is less than 1.414, which means that the area in the green is greater than the threshold. So area in the green is basically our p-value, which is greater than the threshold, and since it is greater than the threshold, we cannot reject the null hypothesis. So our null hypothesis says that our height is still 145 and it is not changed, and we do not have sufficient evidence to reject that claim. So I hope this video has helped you understand p-values and how to use them in hypothesis testing. If you like the video, please feel free to share and comment your opinions. This is my first video on statistics in my video series. I hope you like it, and there will be more good content coming soon. Stay tuned. Bye bye.